Hello, guys. How are you all? Good evening. A very good evening to all of you present over here. Hi. Yeah. So I can see a few people are here live with us. Nikki, Saik, Ashish, OS. Hello, OS. How are you? I'm very good. Good evening. Good evening. Yeah, my day was not that much good. It was okay. Okay. Amazing. So happy to see you after so long. And amazing. So I think we can start our session, right? And today we are almost on time. So let's start it without wasting any further much time. Okay. All right, guys. Yeah. Okay. So today our session going to be, much interesting. So today we will be learning about some more advanced topic. Okay, about sensors, actuators, what are analog signal, digital signal, the difference between them, right? So we'll be talking about all those things. And today's session is really going to be very interesting. It's my promise to you all. All right. So let's start it, guys. Okay. So the first thing, what is the difference between a digital signal and analog signal? Like, I guess you all have heard about digital signal, analog signal, right? But you may not know what is the actual difference between a digital and an analog signal. Okay. So, let me give you just simple example, and you will be able to understand the topic with more clarity, right? So, the example is, have you ever seen an artist performing on the stage and he's singing something, a song? For example, if you went to concert of Arijit Singh, so you can see him performing, right? So whatever he is saying in the mic, it's been amplified through the microphone and through the speakers. Entire, stadium or the concert hall, uh, people, like thousands of people can hear them. But if he, only person, in the stage, he's just singing without any microphone, can you hear? No, right? So actual real life signals are analog signal, which means they are continuous. Okay, the signal is continuous with respect of time, right? So whatever we are speaking, whatever we are, singing, right? Whatever stuff is happening in our real life, those are analog. Okay, all the signals are analog around us, right? So what is means the analog is this are continuous. Okay, so the informations are continuous with respect to time. You guys all know about continuous time graph, okay, discrete time graph, right? So here you can see the analog signal, which is continuous with respect to the time, right? So you can see this is the line, okay? If I want to show you, see, this is a line, right, which is continuous. What is the meaning of continuous? Continuous means if you take any of the point, for example, in this time, if you take any of the point, you will get a corresponding value in the signal, right? So if you take any of these time signal, randomly, if you take anything, you will get a corresponding value in the y-axis. Okay, so if you take anything in this x-axis, you will get a corresponding value in the y-axis, right? So I think I need to know my backgrounds. Okay, yeah, all right, guys. I guess you can see me, right? Yeah, it's fine. Okay, so that's the meaning of an analog signal, where in the x-axis, if you take any value, you will get a corresponding value, right? But in terms of digital signal, we are having we are having discrete values, right? So for some places you will be having the value, for some places you will be not having the value. Okay, so digital signal is basically like a switch. Okay, it works like when we turn on the switch it's one, when we turn off it it's became zero, right? So we can define voltage values like that, right? If like for example, you can see here we are having a step like thing, right? So here it's not continuous. For example, if you take here you will be getting this value, right? And if you take here, you will get this value. But if you take here, you will not get any value, right? This cross means this is not taken, right? So if I take this time here, I'm not having any value. So this is called the digital value, or digital signal is basically needed in order to work with digital electronics, because all the digital electronics works on the principle of binary system, zeros and one. And in order to depict that zeros and one, we use digital signal. So I have given you example of a concert, right? So if you are having a concert and some, singer is singing a song, right? So if a singer is singing, then what happens is the song which he sings, right? What which he song, like whatever he's, speaking, those all are analog signal, and that analog signal is converted into a digital signal in the microphone, and then it's transferred to the speakers, right? So these are the speakers, right? And that analog signal into, sorry, that digital signal into analog signal again, which we hear as an audience, right? So as an audience, we hear that thing. So what is happening here? First thing we are having what? We are having a analog signal, right? We are having a analog signal, AS for say. Then that analog signal is converted into digital signal, okay, right? And then digital signal is transported through wires or cables to the microphones, sorry, the speakers, and that speaker again converts that digital signal into analog signal, right? And this analog signal, what we can hear, we can't hear the digital signal. So that's why in the speaker it's converted again into an analog signal, and then we can hear that, right? So this is what basically digital analog signal means, right? And so they are basically in a continuous range. Okay. Like in a volume knob, whenever you are, working with speakers, you can see the volume knob, right? So you can change the volume by just rotating the knob, right? Or in your household appliance, you can see the fan, ceiling fan. We are having regulators, right? So when you, to change the speed of the fan, you just rotate the knob, right? So that is basically how the analog signals is, transferred. Those are continuous signal. Okay. And this is about a digital signal, which are zeros and one or on and off, right? So it's basically, works as a switch, right? Now, now let's talk about potentiometer. All right. So what is potentiometer? Potentiometer is basically a variable resistor. Okay. So you guys know about resistor? The work of resistor. Resistor is an electronic component which resists the flow of current. Okay. So it's resists the flow of current, or it's decrease the voltage which is going to the circuit, right? So this is a variable resistor. This is how it looks, okay, and it's having three terminals, okay. And what are these three terminals? One is VCC, okay, or the positive terminal, you can say. Another one is our this one. Okay. So this is our ground pin, GND. Okay. Or the negative terminal. And this is our signal pin. Right. So this is our signal pin. All right. So this is how a potentiometer look like, or we can also call it a knob. Why? Because it just act like the similar way we use knob in our speakers to change the volume of our speaker, right? So this is how this works. Now, how does it work? How this internal circuit work is, as you can see, in the left turn, if you completely turn that knob towards the left, right? So that's depicts zero voltage or ground, right? Or ground. And if you turn it completely towards the right, it's became 5 volt, right? And in the middle, it's 2.5 volt. All right. Got it, guys? So this is how the knobs work. The entire circuit is having resistance, okay, and the moment you change the resistance, the voltage also changes in the circuit, right? So in the complete left, what happens is 0 volts, and in the complete right, if you make the knob rotate it, then it becomes 5 volt. All right. Okay. And in the middle it's become 2.5 volt. Got it. Got it, guys. That's it. Any questions about the potentiometer? Or if you're having, you can just ask. Okay. So potentiometer is basically a analog component. Okay. And the signal pin which you are seeing, now, This signal pin is basically the analog signal pin. Okay. So we interface, if we want to interface it with the Arduino, we have to interface it with the analog pin, right? Because we will be changing the analog value. Okay. So that's about the, you know, term. Yeah, OS. Are you having any question? No worries. It will be clear once you start working with it. So no need to worry about that. Uh, I think we can move on. Right. Yeah. Now, the most important thing. How does Arduino reads analog signal? Okay. All right. Let me explain it once more. Okay. Starting from this. So you got to know about what is digital signal, what is analog signal, right? So digital signal is something which is continuous in nature, right? And basically all the signal which we are having in our real life scenario, those are analog signal. So whatever input you are putting, right? If it's about changing the volume, if it's about, switch, if it's about something else, those are basically analog signals, right? So in order to interface those analog signal, we use a component called potentiometer. Okay. So this is also a switch, acts like a switch, but it is variable resistance, which controls the flow of current in a circuit, right? So you know a basic thing, right? If we change the voltage, if we change the resistance, the voltage also change, right? You know Ohm's law, right? V equals to IR, right? So I is equals to V by R, right? Or voltage equals to IR. So if the resistance is changed, the voltage will also change, right? So you know Ohm's law, right? If I write Ohm's law, Ohm's law, right? So this is based on Ohm's law. What is Ohm's law? V is equals to IR, right? So if you change the voltage, if you change the resistance, the voltage will also change, right? No issue, you're not that much late. We are just talking about the potentiometer and then we will be moving towards our main section. All right. So this potentiometer works on the basis of Ohm's law, where if you change the resistance, the voltage in the circuit is also changing, right? So in the knob, what happens? You have a rotatory, this knob, and when you rotate it, just like if you change the volume of a radio or your speaker, so if you rotate this knob, if you turn it entirely to the left, the circuit, zero voltage will be flowing. There will be no voltage, right? And if you rotate it towards right, the voltage will start increasing. And if you turn it entirely to the right, it will become 5 volt. Okay. And if you put it in the middle, it will become 2.5 volt. All right. I hope now it's clear. So what it does, it just changes the resistance, okay, in a circuit. Previously, what we used to do, we used to interface our LED, right? This is our LED, and we put one single constant resistance, right? For say 1 kilo ohm resistance, right? But right now, if we use this potentiometer, we can change the resistance in the circuit. We can make it 2 kilo ohm, we can make it 3 kilo ohm, right? By rotating the knob. So that's basically what potentiometer means, right? So this is about potentiometer, all right? And let's move on. Now let's talk about how the Arduino reads the analog signal, right? So as I am having this potentiometer, right? But how my Arduino will read the information or read that I'm changing the resistance. Okay. So this is how it's understand. So first we have to interface our sensor. So right now today our sensor is potentiometer, right? potentiometer, or potentiometer is our sensor today. Now, this sensor will send a voltage between 0 to 5 volt. Okay, by varying the resistance, it will give a voltage between 0 to 5 volt, right? And and it will be depending upon the position in the knob. Okay, so if it's in the middle, it will be 2.5. If it's completely towards the left, it will be 0 voltage. If it's completely towards the right, it will be 5 voltage, right? So by changing the knob position, we can change the voltage, and basically our sensor will be giving the output of that voltage, right? Now, in the Arduino, we will be having one ADC, right? What is this ADC? It is known as analog to digital converter. Okay. As in the previous example, I have shown you, right? Here. Here, what's happening? When Arjit is singing or performing, his voice is an analog signal. And that analog signal is converted into digital signal through that microphone, right? So here, in our case, this Arduino acts like a microphone, and and it converts. Okay, so it converts this analog signal into digital signal. Okay, and that digital signal we can use it in order to work with our project. Okay, so this Arduino chip converts the voltage into numbers or code which can be understand by the computer. Okay, so how it does? So whenever we interface a potentiometer, the computer sees that number. Okay, that voltage is converted into number, and converts the number into yeah. So why it's doing the show? Yeah. So you can see that number is between 0 to 1023. Okay. And 1023 means 5 volt. And if the number is 0 means 0 volt. Got it? Got it? See, this will be more clear once we start working with it. But the main thing is Arduino, how this Arduino reads that analog, inputs. Okay. So it's basically means like whenever I'm interfacing one sensor, it's read or it gives the output of 0 to 5 volt, and we capture that voltage using our analog pins, right? And that analog pins convert that voltage into understandable numbers, and that number can be 0 to 1023, right? And that 0 to 1023, this range, 0 volt, 0 means 0 volt, 1023 means 5 volt. Okay, that's it. That's it. All right. Now, let's talk about what is PWM. Right? So, if you are working with Arduino, you have heard the term PWM pin, digital pin. What is this? What is this? So, digital pins and PWM pin is just like, you know, they are similar kind of. All right. So if we talk about PWM pin, what is PWM pin? PW means pulse width modulation. If you don't know about it, no need to worry about it. Okay, the spelling is mistaken here. This is modulation. So pulse width modulation. All right. So the pulse width modulation, what it does is, if I want to explain it to you in simple words, it's basically digital pin which mimics analog signal, right? In our Arduino board, we are having some digital pins, right? So here we are having digital pins, here we are having analog pins. Analog pins are used for, getting the signals, right? So if we have some input as analog signal, we can take it, right? But if we want to send analog signal, then we can use the PWM pins, right? So in the digital pins, 13 digital pins, there are few. PWM pins, which can mimic, which can mimic the analog pins. Okay, analog signal. It can send analog signal using digital pins in the form of PWM or pulse width modulation. Right. So it converts basically the digital signal into somewhat analog signal. Okay, not completely, but it's somewhat make the signal analog form. All right. It's just basically if you want to connect it with the example which I have shown you here. Right. So first, what's happening? The analog signal or the song or the actual song which the singer is performing is converted into digital signal through the microphone, and then that digital signal is transported to the microphone, sorry, the speaker, and that speaker again converts that digital signal into analog signal. All right, and that analog signal we can hear. All right, so you can just assume it like it's the speaker which convert, it's PWM, basically a speaker which converts the digital signal into analog form which people can hear. All right, all right, and we can use it for dimming the LED light in a circuit. I know it's quite boring, but it's needed because you must know what is PWM pin, right? Now, yeah, let's move on. All this boring things done. Right now, we have to work with our simulations. Okay. All right, guys. So let's move on. Mm, yeah. Okay. All right. So I think just a minute, guys. Or okay. Now let me just open the workfree. All right, guys. So I we are right now in the workfree. And now we will be looking into how to interface our potentiometer and what are the PWM pins available in our Arduino Uno, right? So here, if you zoom in into the Arduino board, what you can see is here we are having pins, right? So these are the power pins where we are having V in, ground, 5 volt, 3.3 volt, and in the analog pin we are having six analog pins of A0, A1, A2, A3, A4, A5, right? And here we are having total 13 digital pin, and out of this 13 digital pin, we are having one, two, three, four, five, six PWM pins, right? So this pin can be used as PWM pin where this, arrow is showing, right? Wherever this, arrow is showing, it means it's a PWM pin, like pin number 3, 5, 6, 9, 10, 11. And this can be used as a PWM pin or as an analog pin, analog output pin. All right. Got it, guys? I hope it's clear. Right. Now, let's dive into our pictoblocks. Okay. No, no, not pictoblocks. Let us first interface our potentiometer with our Arduino. Right. So, what we have to do is we have to first, uh, bring one breadboard. Right. This is a breadboard. So what is our first activity is? Our first activity is, or the challenge is to, you know, okay. So our first goal is use the potentiometer to control the brightness of LED. So we have to control the brightness of a LED using potentiometer, right? And the challenge is here is our input will be like 0 to 5 volt, and then our Arduino will convert it into 0 to 10323, right? In this number. But our PWM output is just only 0 to 255. Right? This is our main challenge. But we will solve it with the mapping. I will show you how to do it. Before that, let's move on to our, you know, yeah, got it. So here. You can see we are having our Arduino board, we are having our breadboard, and in order to control the LED brightness, we need a LED definitely. We will put it in the breadboard. All right. Now what we require is a potentiometer. Just search potentiometer and you will get it. So you can see we are having this potentiometer. As I have discussed, we are having one ground pin, we are having one VCC. If it's completely to the left, it's becoming ground or it's the voltage is zero. If it's completely towards the right, it's become VCC or completely 5 volt. And if it's in between, right? So if it is in the middle, then what happens? Then we are having 2.5 volt, right? And what we need to do is we need to connect it with the ground VCC and this pin into the analog pin, any of the analog pin we want, right? So I will put it in the breadboard, right? Now what I will do is I will just take one ground, common ground, and I will connect it with the breadboard. I will take one common VCC and connect it with the 5 port, right? And what I will do, I will just connect this ground pin of the LED to the ground, common ground, and then I will connect the ground pin of the potentiometer with the ground, and then I will take the VCC and connect with the positive volt. Now, what I will do is I will just take this signal pin, SIG signal pin from the potentiometer, and I will connect it with my analog for say A0 analog pin, right? Then I will just connect the LED pin, LED positive pin with the PWM pin for say 3, right? So this is our connection to control the brightness of a LED using potentiometer and interfacing it with the Arduino, right? Now, this is it. It's very simple. If I show you again what's happening, we just have taken the ground pin and the VCC or 5 volt pin common in the breadboard. Then we connected the ground pin of the potentiometer with the ground, VCC with the positive voltage, and the signal pin with the analog pin 0, A0, right? Then we have interface one LED. We have taken the common ground and then the positive pin of the LED we connected with the PWM pin 3. You can take 5, 9, 10, 11. But if you take 4, pin number 4, it will not work. All right. So that's it about our connection. Now let's move into the code. So here I am into the PictoBlock screen. And in the PictoBlock screen, you all know we have to select the blocks, right? And once we select the blocks, what you need to do is we have to select the board. Our board is Arduino Uno and just cross it. And once we selected Arduino Uno, go to the upload option. Once we are here, the first thing what we need to do is we have to grab this block of Arduino Uno, which says when Arduino Uno starts, right? You know from our previous session. Then what we need to do is we need a forever loop in order to run the program forever. All right. Now, what you need to do is you have to create a variable. So, what will be this variable? So, this variable will be, checking the input of the potentiometer. So, if I'm rotating the knob, how can I, understand or how can our circuit will understand that our knob has been changed or moved? For that reason, we need a variable which will be storing the value of the knob, right? So if the knob is turned slightly towards right or left, it will change the value of this variable. So for example, if I take the variable as brightness, BRIGH, brightness. Yeah. So I have taken this variable brightness. Now what I will do, I will first grab this, this block, which says set brightness to 0. Okay. Okay. Now, do I need to set the brightness to 0? No. What I need is I will just grab this read analog pin 0, A0. So what we did, we have interfaced, I'm sorry, yeah. So we have interfaced this potentiometer with the analog pin A0, right? We have interfaced with the A0. So what I will do, I will check from the A0 that whether my knob has been turned or not, right? For that reason, we will be using our A0 pin. So what I'm doing here, here I have taken this forever loop and it will check forever and it will check that it will read the analog pin A0 and it will store the value into this brightness. Now what I have told you previously that the knob can only change the value between 0 to 5 volt, right? But the analog to digital converter converts that voltage or that analog signal into numerical numbers and which is 0 to 1023, right? So this is what 0 to 1023. Now what I will do is uh, I will next put this block which says set PWM pin 3 to output as 255. Now, what's happening here? Understand this. Okay, try to understand. My analog pin A0 is reading the output or input, sorry, reading the input from the potentiometer between the value 0 to 1023. All right. But in the PWM pin, right, which will be controlling the brightness of the LED, it's just its range is between 0 to 255. You can see its range is 0 to 255. But I'm having the analog value between what? 0 to 1023. That means directly we cannot put here the brightness variable, right? So what we need to do? We have to first map. So we have to first map that 0 to 1023 value into 0 to 255 value. Then only if we turn our knob, as per the knob is moved, it will change the brightness of the LED or the voltage which is going towards that LED will be changed. All right. All right, guys. Got it. Now, for that reason, we need this block which says map and I will put it here. Right. But what I need to do is in the place where it says map 50, I have to change it with the brightness variable. So what it will do? It will map that brightness variable, which is currently from, this is, see, the values are interchanged. We need to interchange this value. Right now, our brightness variable is having values from 0 to 1023, right? So right now I'm having 0 to 1023 and I want to convert or map this into 10. I need to convert it into 255, 0 to 255. So what it will do? It will map this brightness variable from 0 to 1023 and it will change its corresponding value into what? In the range of 0 to 255. That's it. That's it. We need not to do any other codes. That's it. Right? Now what you have to do? Just you just have to copy the code, right? Now paste it. Okay. All right. So we are already having our circuits done. Run it. All right. So again, it's same. Server load is high. Let's wait for some time and we'll see the magic. Right. Let's wait. Okay. So while it's happening, let me explain you the code, the C++ code, which the Arduino understand. So here we have taken one variable that is brightness, which is a float value. We can take it int also, integer. Now we have set up the pin of 0 as input. Okay, so this analog pin A0 as input, this pin 3 as output. Okay, pin 3 as output, and we have make the variable, uh, whatever the input variable which we are having, brightness, is checks the value of A0, right? And then it is between 1, it is between 0 to 1023. And then we have taken this analog right, or this PWM pin will give the output to this LED, which will map the value of 100 to 1023 into 0 to 255. Okay, our code is running. Let's see, let's check. So right now it's completely towards the left. That means our voltage is 0, right? And 0 means our LED will not glow. Let's change it. Can you see the brightness of the LED is changing? Okay. So see. Right now it's completely 5 volt, right? And the brightness is increasing, is in the maximum. Now if I change the resistance, or I will change the knob, I will turn the knob towards the right, and it's turned off. Why? Because it's now 0 volt. And the moment I again turn it towards the right side, it's glowing. Okay, it's glowing brighter. Got it? Got it, guys? Show me the thumbs up. Okay, show me the thumbs up so that I can see you are understanding this. All right. So the moment we are turning the knob towards, right side, it's glowing brighter. And the moment we are turning it towards the left, it's, not glowing that much. Okay. And it's ultimately turning off. Okay. All right, guys. Amazing response. Now let's let's move on to our next part. And so our next part will be about uh, all right. So we have understood how to interface a LED with our microcontroller Arduino. And how can we control the brightness of that LED using a potentiometer, right? So you have faced this challenge. Okay. So you have faced the challenge of how to, interface it, then, you know, how to, the input which are getting is 1023, 0 to 1023, but the PWM output can only get to the range of, which accept the value of range of 0 to 25. So we map the values, and from the input which is having 1023 maximum, to change the output of the maximum value to 225. How we use that function, how we use that, palette blocks, right? So that's it, guys, how you can interface LED, right? Now let's move on and let's talk about servo motors. So right now we came into the picture of actuator, right? Now our actuator is micro servo. Right? So if I want to show you how this micro servo would look like, let me just show it to you. Okay. So I think you can see this is a micro servo, and also you can see in the picture how it looks like, right? Now this micro servo looks like a motor, right? It somewhat works also like a motor, but the main difference is that it can change its, position in terms of degree, right? So it has a motion of 0 to 180 degree, right? And as per that, it can move. As you can see in the presentation also, that our servo motor is having restricted motion of the range of 0 to 180, right? So it's having a range of motion from 0 to 180, and you can make this servo move into any position you want in between the 0 and 180. If you want to position this servo motor into 30-degree, it will turn it to 30-degree, right? If you want to turn it to 60-degree, it will turn it into the 60-degree. All right. All right, guys. Amazing. Now, what are the use of this servo motors? So, have you ever seen RoboFi, right? So, in the countries like USA, China, or the European countries, they, organize the RoboFi. So, where students like you, me, they build their own robots and they make the robot fight, and whoever's robo is more strong and more reliable and can destroy other robots, they win. Okay. And how they make the robots move, they use this servo motors, which makes the robot move. For example, if you want to make a leg of a robot, you use this servo motors, right? And you program it such that it moves into that particular angle of motion, like 30-degree, then again 40-degree, then 50-degree, then 60-degree. That's how you make it walk, right? And also, if I want to show you, uh, can you give me that? This one. Oh, uh, okay, guys. Now, let me show you something which will make you able to understand uh, how it's work, right? Another example, if I want to give you, can you see this? So this is basically a robotic arm, or more specifically, it's called a six-axis robotic arm. Now, what the six-axis robotic arm does it can, move. It can catch any object or any material, and then it can put it somewhere else, right? So how it does? You can see the servo motors, right? So using this servo motors, it's able to move its arm, right? So it's having a degree of motion. For example, it can move into this 0 to 180-degree, right? And the base motor can also move into 0, 180-degree. And that's how it's we can use it in the robotics, right? All right. Now let's move into the main topic. How we can interface a servo motor into our Arduino, right? And if I would like to tell you, like, if we move into our next part, yeah. Now, uh, this is our servo motor, right? Now, for the case of LED, we use PWM pin, right? Uh, Now, for the case of servo motor, we need not to only interface with the PWM pin. We can use the digital pin also. But the only thing is, we have to make sure the mapping, right? As we know, if we want to use the potentiometer in order to change the degree of rotation of this servo motor, so we have to keep this thing in mind, that our servo motor is having a range of 0 to 180-degree, right? So previously, for the case of our LED, we use PWM pin, and that's have a range of 0 to 255. But in this case, we are having a range of 0 to 182. So in order to map this, we have to keep this thing in mind, that the potentiometer gives us the input of 0 to 1023, and we have to convert it or map it into the range of 0 to 180, which the servo motor has. Right? Got it, guys? Amazing. So let's do our second activity. What is that? Our second activity is to turn this servo motor as per the knob is turned, right? So if the knob is moved towards the right, it will be in the 0 degree, sorry, the left. And if it's turned towards the right, it will change its, degree of motion. And in the extreme right, if we turn the knob, it will become 180 degree. Okay. So we want to make that thing happen. So let's do that. Do you think it's hard to do? It's very easy, right? It's super easy, right? So first, what we should do is first we will go to our you know mm, our pictoblocks. Yeah. So here we are into our pictoblocks. Sorry, in our workflow. All right. So in our workflow, let's first make the circuit. Let's close it. All right. So I will just delete everything. Delete the LED. Okay. So I will delete this also. Let's make it fresh, right? So what are the components we require? We require a breadboard, then we require a servo, right? So we require a servo motor. This is our servo motor, okay? We require our potentiometer, right? This is our potentiometer, right? And let's put it here. This is our servo. Now, in this servo, you can find three pins, all right? Here you can see this is our servo motor, right? It has three pins. Now, what these three pins define? What are these three pins? Can you guess? Can you guess, guys? Write on the chat box. You can guess it. What are these three pins? It's similar to this, potentiometer. Just this is the hint. Tell me, what are these three pins? Yes, I know you are guessing right. So, these three pins are basically one is VCC, one is ground, and one is signal pin. Right now, which color pin is which pin, right? So as you can see, we are having three color pins, right? One is brown, red, and yellow, right? So this red pin is our positive pin or VCC pin. This brown pin is our ground pin, okay? And this yellow pin is our PWM pin, right? Or you can say it's the digital pin, right? So you can interface it with the PWM pin. Also, if you want to interface with digital pin, then also it will work, right? So because like for our case right now we will be using the PWM pin because for the simplicity we are using pictoblocks, right? So for using it in the pictoblocks we need to use the PWM pins. But uh, if we are working with C++ directly, we can use the digital pins also because on that case we will be coding it. So for coding purpose, we can use the servo library which we are already having in our C++ programming. So on that case, we can use any of the digital pin. But for our case, we are when we are using our pictoblocks, we require to interface it with the PWM pin. Right? All right, now let's talk about the connections. So as you know, here we need PWM pins. Sorry, we require ground pins and VCC pin. So what I will do is I will just take the ground pin, put it in the breadboard, and make a common ground. And then I will take the 5 volt from power supply and I will put it here. So I'm having 5 volt and negative volt in the breadboard. Now, I will just connect the VCC of the potentiometer with the 5 volt. I will take the ground of the potentiometer and I will interface it with the negative term, right? Similarly, for the case of our, servo motor, I will take the VCC or the red pin and I will connect it with the positive. And I will take the ground pin and I will connect it with the negative terminal, right? So power supply done. Now let's interface our potentiometer signals into the analog A0, right? Because we are taking the analog signal as input. Next, we will take the PWM pin or the yellow pin and we'll connect it with pin number, say 3, right? So you can take any of the PWM. All right, guys, I'm so sorry. We were having some network issue. That's why missed some of the things. All right, let me show you again the connection, how to do the connections with the servo and potentiometer, right? So for that, what you need to do is uh, you need to have one potentiometer. You have to just connect the ground pins and VCC pin as per the 5-volt pin and the ground pin. And then what you have to do is you have to take the ground pin and the VCC pin from the servo. You can see the red color pin we are having as our VCC pin, right? And the brown color pin is our ground pin. You just have to connect that ground pin into the negative side and the positive terminal or the this red color to the VCC. All right, guys, amazing, fine. Now that part is done. Then what we have to do is we have to take this signal pin of the potentiometer and we have to make it connected with the A0 pin. All right, and then the signal pin, the PWM pin from our servo motor, we have to take it and we have to connect it with any of the PWM pin, right? So we are having PWM pin as our, oh, I'm so sorry. Yeah. So I'm having my PWM pin as P, 5, 6, 10, and 11, right? So these are my PW pin. All right. Now our connection is done. This is all about our connections. Right? Now, if our connection is done, what the thing which is left? The only thing left is our picto blocks, right? So let me remove all those things and let's start it from the beginning. How to do it? Okay. So I will just the first part is go to Arduino Uno, select the block which says when Arduino Uno starts. And when we are having this block, what is the next part? That is go to control, grab this forever block, put it here, right? And go to variable, create a variable. For our case, we are having servo, right? So we will take the variable named servo, right? And we will create the variable named servo. Then what is our next, thing? We have to select this block, which says set brightness. Now this brightness, we have to change it to servo, right? And okay, all right. So we have to take this block, which says servo. And then what is the next part? Do we need to set the servo to zero? No. We have to check the analog pin A0 or the potentiometer's input, right? For that reason, what we will do, we will just grab this block which says read analog pin A0. Right? And after, clicking on this pin, read analog pin A0, what we need to do? We just have to, you know, uh, yeah, I'm so sorry because of the network issue, but we are trying our best. Don't worry about it. But in the recording, it will be fine. Okay. So after the session ends, you can check it. Okay. Fine. So now what you have to do is you have to just go to your actuators. So our servo motor is the actuator. And you have to find this block which says set servo motor servo on 11 to angle 30. But we have interfaced our servo motor in the PWM pin 3, right? As you can see, we are having total 6 PWM pin, 3, 5, 6, 9, 10, 11, right? So I have interfaced with the 3. You can interface it with the 5, 6, or any other pin you want, right? Now, what this code will do, it will just set the, this servo motor into the position 30 degree. But do you just only need to put it on the 30 degree? No, I have to check the potentiometer, and as per my knob, as per I'm moving the knob, I will turn my this servo into 0 to 180 degree, right? For that reason, what I need to do is I have to map it, right? I have to map it and I have to go to Arduino. I will have to find this particular block, put it here, and what I will do, I have to map what? I have to map the variable servo, which is reading the analog pin, right? Right now, what this, servo variable is having, the value. Its value is right now 0 to 0 to 1023, right? But my servo has the limit of the angle 0 to 180. Okay. So for that reason, I have to map it from 0 to 1023 into 0 to 180. Okay. So what I have to do? I have to just change the value 0 to 1023 from 0 to 1023 to 0 to 180 degree angle. Right? 180 degree angle. All right. That's it, guys. That's the code. That's the code of interfacing a servo with the potentiometer. Okay. So you have to just copy it. Then um, you have to just, you know, paste it, right? And once you run it, you may get one error which says that this includes servo.h library is not installed. So there will be an option which will be telling you to install that library. Click on it. Once you install it, then again start the simulation and it will work, right? So right now you can see I will just run it. Okay. So now you can see it's running, right? This is our code which we get from the picto blocks, and this is what we can see. Here you can see right now our knob is completely to the left side, right? So that's why our servo position is also in the zero. Let's see whether if we move it towards the right, does the servo's position also moves or not? Okay. So if I move it, you can see it's moving, right? And if we are at the middle of the knob's position, you can see our servo is in the 90-degree position. And if I'm moving it more, and once we reach at the complete right side, my servo position is right now at 180 degrees. Got it? And if I turn it again like this, it's again comes to zero. And if I'm turning it here like this, you can see it's moving. Okay. So can you guess where we can use it? Huh? Have you ever played with RC car, remote control car? So you have seen that we can steer the, car towards right or left. That's what the servo motor does, right? If we, it's just act like a steering. You can see the way I'm moving the knob, it's moving the servo motor. All right, got it. That's it, guys. It's very simple. Can you see that we have start with just blinking LEDs with Arduino, right? And now we have reached on that position where we can interface a servo motor. Also, we can, control it with a knob potentiometer, right? Amazing, guys. So that's about today's session, guys. And this is how we have came into the end of our session. And I'm really thankful and I salute to your dedication, guys. Uh, I can see how much efforts you are putting, right? So this is how we have successfully done interfacing our servo, uh, where we can control the servo using our knob or potentiometer. And, uh, you know, so see, this is about our today's session, guys. And I congratulate you all for, staying this much, uh, with our session. Thanks for the support. And definitely, guys, you are going great. You are working great. I appreciate that. Just stick on to this session. I, promise to you that you will learn a lot of things. I will make you that capable that you will be able to participate confidently in any hackathons or any competition related to robotics or IoT or hardwares, right? So it will be like, I can do it, right? So you will be able to participate on any of these, competitions or hackathons, all right? So that's it, guys. Thank you so much. And we will meet you in the next session. That's all for today's. And yeah, definitely regarding few issues are happening, like many people are not getting the scores. So yeah, that's happening because I'm checking all the response or submissions manually, and it takes some time. So definitely you will be getting your response. No need to worry about that. Although if you're not getting for a long time, you can just text me. I will check it and I will let you know. So that's it. And regarding our next session, it is most probably on third, but we will see. If not third, we will change it to fourth. And yeah, you will be getting the recording of these sessions, so you can check it after the live session ends. And whichever part you have missed, you can check it again, right? So that's all, guys. Thank you so much. See you again. Okay. Bye bye. Take care.